Hale, today we are going to talk about what happens when we have segments in triangles that create proportions. And we talked in class together about proportions being equal fractions. So proportions are equal fractions. And we have some notation on these triangles. You'll see these red arrows, and that's something we saw previously this year, but this is a reminder that those red arrows mean that those are parallel lines. So what we have happening here is we have a triangle, and then we have this segment inside this triangle that's parallel to one of our sides. And what happens is it creates some proportions, some proportional relationships that help us find side lengths. And so this segment in the middle of this triangle is splitting this side up into two pieces and splitting this side up into two pieces. And that's why we sometimes call this the side splitter theorem, because we have a segment that's splitting a side, or splitting two sides. And so over here we have two small pieces, and then we also have this whole side that before we split this up existed on its own. So this little piece that was 10 and this little piece that's 8 didn't exist until this segment split this side up. And so we would just have this whole side of the triangle. And then we have, if I extend this, I like to extend my side splitter. I have a piece of this side that's to one side of the side splitter, and then over here I have a piece that's to the same side, and then 8 is on the right here, and then there's this piece we don't know to the right here. And so we just are going to match up like parts, and we can create proportions. For example, in this triangle, when I have this side splitter, I know the smaller piece to the left of my side splitter on this side, and so I'm going to start writing a proportion. I'm looking for the smaller piece to the left of my side splitter on this side. Notice I'm building two fractions that are going to be equal to each other, and the pieces that correspond, much like in congruent triangles, are going to be in the same spot. Now I know how long this side is. This whole side of the triangle is 45, and it's going to go with the question mark because they come from the same parts. I know how long this whole side is because I know these two pieces. It's 10 plus 8, which is 18. And so now I have a proportion that I can solve by cross multiplying. I can do 18 times question mark and 10 times 45. I'm just going to do that multiplication. And then I'm going to go ahead and divide 450 by 18. And I get 25. So that missing piece, this piece right here, is 25. So this is one of those things that gets easier the more you do it. The more you do these, the quicker and more clearly you'll see the parts that go together. I always like to extend my side splitter. And so again, I am looking for this piece to the right of my side splitter. And so then on my other fraction, I need the piece to the right of the side splitter, so that's 5. Over here, I know this whole side of the triangle is 18, and I can add these 2, 4, and 5 together to get this whole side of the triangle, which is 9. And again, we have a proportion to solve by cross multiplying. 9 times question mark and 5 times 18, which is 90. If you struggle with proportions, you should probably show that step. 5 times 18 here, and then do the math, do the multiplication. I'm going to divide both sides by 9 and get 10. So that missing piece to the right of the side splitter down here is 10. Let me do one more. This is looks different, but it's pretty well the same. I have some parallel lines. The relationship still holds true that this line in the middle that's splitting up these two lines, splitting those sides, creates these fractions. Sorry, I'm having a horrid time drawing a straight line using my tablet. But you can see how this line gets broken up, split up, and this line gets split up. And so over here, I'm looking for the whole distance between that point and that point. That's what question mark represents. And so then over here, I can find this whole distance, 8 plus 6. And then if I extend my side splitter, I know 20 is to the left. To the left over here is 8. And I can cross multiply. (14 times 20 is 280. Divide both sides by 8 and get 35. So again, this takes some practice, so we're going to ask you to practice one. If that was confusing to you, you're not prepared to do this one, please do ask for help first, and then give this one a try, and I will display the answer. So hopefully you got 21. Something similar. Your fractions might look different than mine. There's some different ways to set these up. You found the way that you're comfortable with and use that process every time. If you got a different set of fractions but you got the right answer, then you're good to go. If you didn't get the right answer, please do ask for help before you move on to the next type of relationship. So we have our side splitter, and now we have an angle bisector. This segment in this triangle is called an angle bisector. It's an angle bisector because it's cutting this angle over here into two congruent angles. That's what those little arcs mean, that these two smaller angles are congruent. So we've cut this into two. Bisect means to cut. We've cut this into two equal angles. And so again, we create some proportions. So I'm going to extend my angle bisector much like I did with the side splitter. And from doing this a lot, I see fractions get formed just by highlighting that. I look right here and I see 10 in question mark. That can be a fraction. And then I look right here. I can create a fraction here with 3 on the bottom. And then some number here that represents how long this piece is. Not 9, because 9 is this whole side. I can figure out this piece by doing 9 minus 3 and getting 6. And once we get this proportion, it's a solving proportions problem. And that's not a new idea. 6 times question mark, 10 times 3. Divide both sides by 6 and get 5. So this side over here is 5. So again, whenever I see this segment making two congruent angles, it's an angle bisector. That means it's created some proportions in this triangle. And I like to extend my angle bisector. I have this fraction I can see right here, 25 over 10. And then I have a fraction here. We don't know what this piece is yet. We need to represent it. But the bottom of this fraction is question mark. To get this piece over here, we did 9 minus 3. So we did the whole side minus the piece that we knew. We can do the same thing here. The whole side is 21, and we are going to subtract the piece we know, or we have labeled question mark. and then we can cross multiply. So 25 times question mark, and then 10 gets multiplied. It's distributed by both of these things. So 10 times 21 and 10 times question mark. And now we can solve. I'm going to move this 10 over. It's going to become positive 10 question mark. And you're welcome to change question mark to X if that makes you more comfortable. The program that I use to generate these problems just uses question mark instead of X sometimes. Then I could divide 210 by 35, and I can get 6. That missing piece is 6. So one more time, I have an angle bisector because of these two arcs. Tell me those two angles are congruent, created by this segment cutting this bigger angle. I have these fractions that are created. There's one, question mark over 7. There's another one, 6 over 14. And I can cross multiply 14 times question mark and 6 times 7. I'm going to divide 42, or divide both sides by 14 to figure out that that missing piece is 3. This missing piece is 3. So again, as we say all the time, please do ask for help before you try this if you are confused. Don't go ahead and do it if you're confused. Then give it a try and check your answer. So again, your fraction might look slightly different than mine, but you should get 12 as an answer. If you didn't, please do ask for help so we can figure out where the mistake is, so you can fix that mistake before you go on and practice. As ever, we have 8 practice. Take your time on these. Always ask if you get stuck, and good luck.